Welcome back to Graphing Equations. This will be the last video on parabolas in the Year 11 course. In this video we're going to be determining the equation from a graph. So before we start we need to remember we've got three forms that quadratics can be written in. The first and most common is the expanded form, which is y equals ax squared plus bx plus c. So we'll call that expanded form. Expanded. Then we have turning point form or vertex form. Y equals ax minus k squared plus h. So that's turning point form. Turning point. Then we've also got factorized form. A is x minus d, x minus e. So there we go, three forms. And each for useful for different things. Expanded form, we've got y-intercept is c, so it's useful for the y-intercept, which equals c. Turning point form is obviously useful for the turning point. Turning point, which is found at kh. And factorized form is useful for x-intercepts. Intercepts, which are found at x equals d and e. So there we go. That's sort of like our key knowledge that we know and that we're going to use in order to find the equation for quadratic graphs. Okay, so let's look at our first example, and here it is over on our calculator screen. And you can see that we know a couple of things. We know that the turning point is here at the origin, and we know this extra point here, which is when x is 2, y is 5. So we're going to use that information to choose the most appropriate form and use that form to find the equation. So as our end result, we almost always want to write out the final result in expanded form, just because that's the convention, and use expanded form to compare two quadratic equations together. So we want our final result in expanded form. So for this one, we know the turning point is the thing that we know. So we're going to use turning point form. So let's say this is example 1. We know that the turning point is at the origin at 0, 0. So we're going to select turning point form by putting in our turning point with 0 and 0 into it. So we've got y equals a times x minus 0 squared plus 0. So because these both are 0, we can neaten this up to, this collapses just to x squared, so it's ax squared. Okay, now let's use our second piece of information, this point here of 2, 5. So we can sub in the point 2, 5 into our equation. So when x is 2, y is 5. So y is 5. We're trying to figure out what a is, and x here is our 2 squared. So we've got 5 equals 2 squared is 4a. So rearranging that, we could divide both sides by 4 to find that a is 5 quarters. And now we're basically done. We can now write down our equation, which is y equals, going back to this step here, y equals a being 5 quarters x squared. And there we go, we have finished example 1. Okay, let's look at example 2. So let's go across to our next page. Here's example 2. Okay, so in this example, once again, we know the turning point is 0, 3, and we know this extra piece of information, minus 3, 1 is another point. We don't know the x-intercepts, as you can see, we're not exactly sure on their precise location. Okay, so let's follow the steps we did before. So we've got our turning point, which is at the point 0, 3. So we're going to select the turning point form as the form to use. So y equals a x minus 0 squared plus 3. Okay, so here we have, let's neaten this up. We've got a 0 in there again, so we can neaten it up to ax squared plus 3. Now we're ready to use our extra piece of information, our minus 3, 1, being a point, minus 3, 1. Substitute that in, whoops, stop. So y is 1, when x is minus 3, plus 3. So minus 3 squared is 9a plus 3. Subtract 3 from both sides, gives minus 2, 9a. Divide both sides by 9, gives minus 2 on 9 for a. Now we're ready to write our equation, going back to here, but putting a in. So maybe I'll make it really clear what I'm doing. Y equals minus 2 on 9 x squared plus 3. So there's that example 2. Okay, let's now hop across to our next example, example 3. Alright, so here we've got a bunch of different information. We don't know the turning point this time, but we do know the two x-intercepts, and we know this extra random point, minus 1, 8. So we know the x-intercepts, so we're going to use a factorized form, the one that tells us the x-intercepts. So we've got an x-intercept at d and e, so that's at 0 and 3. So d will be 0, e will be 3. So x-intercepts are at 0 and 3. So we can write y equals a x minus 0, x minus 3. Neaten up the 0 bit, y equals a x minus 3. Okay, now we're ready to use our extra piece of information, this point minus 1, 8. So minus 1, 8. So when x is minus 1, y is 8. That is 8. So minus 1 for this x here gives minus a, minus 1, minus 3. So minus 1 take away 3 is minus 4. So we've got 8 equals minus a times minus 4. Minus times minus is positive. So we've got 8 equals 4a. So dividing both sides by 4, we get a is equal to 2. So there we go. We can now substitute our value of a into this equation, giving us y equals 2x x minus 3. And that example is complete. Okay, so let's do now, I think this will be our final example, example 4. Here it is. So we know a turning point and we know the y-intercept over there as well. So, okay, so the turning point we know. Turning point is 1, 6. So we're going to use turning point form. Y equals a x minus 1 squared plus 6. Okay, now we're ready to use our extra piece of information, this point 0, 8. 0, 8. So when x is 0, y is 8. 8 equals a 0 minus 1 squared plus 6. So minus 1 times minus 1 is 1, so we've got 8 equals a plus 6. So a must be 2. And our final equation from this step here, I'll write it at the bottom though. We have y equals 2x minus 1 squared plus 6. Now, with all of these examples we've done just now, remember at the start that I said it's good to write everything in expanded form? Well, I haven't been doing that, but I'll just do it for this very last example for you to see what I mean. So writing this one in expanded form, we've just got to expand the brackets out. So we've got y equals 2. Now the x minus 1 squared will become x squared minus 2x plus 1 plus 6. Now we've got to multiply this 2 from everything in the brackets. Y equals 2x squared minus 4x plus 2 plus 6. So it'll be this same thing all again. Y equals 2x squared minus 4x plus 8. And there we go. We have finished. Excellent job. That is the end of our topic on quadratics. On graphing quadratics anyway. So see you in class.